Okay, our objective for this video is I can determine if a relation is a function. This is going to be broken up into two, maybe three videos. I'm going to try and do it in two. What we just need to understand the difference in all of this vocabulary. It's a pretty vocabulary heavy section. We're talking about relations and functions. A relation is a set of ordered pairs. Okay, so if we had a table, that would be one way of setting a relation. A relation is a set of ordered pairs. So a table is an easy way to do that. You could also just have a set of like 0, 3, 2, 1, etc. So if we have an x and a y, 1, 2, 2, 4, 3, 6, 12, 18. Okay, any of these, this would be a relation. A function is a relation, but a relation is not always a function. A function is a relation in which each input is assigned exactly one output. Okay, so if we have an input of 1, output of 2, input of 2, output of 4. What we don't have is an input of 1, output of 2, input of 2, output of 2. Okay, so they each have to have their own output, and it can't be the same as any other output. But again, we could have a table like this and have our x and our y. Our x is our input, that's the one we can change, our independent variable, and our y is our dependent variable because it depends on what x becomes. So we could have 0, 2, 4, 6, 8, and 1, 3, 5, 7, 9. And that would be a relation where every x value has its own y value output. Okay, that's a function. The domain is the set of inputs. Another way of saying that is our x values. Okay, so that is our x values. So if we were to look at the domain of our function, this one, then our domain would be 0, 2, 4, 6, 8. Our range then is our set of outputs, and we know those as our y values, right? So in this case it'd be 1, 3, 5, 7, 9. This one would be 2, 4, 6, 8. Okay, now we have continuous and discrete. So there's two different kinds, and this is very noticeable in graphs, but it can be in tables as well. If it's continuous, it is a solid line. It continues to go, like that means all the points on the line are part of our function. When it's discrete, there are only certain numbers that work, right? And if you think back to when we were doing standard form linear equations not too long ago, when we were doing standard form equations, we'd have something like 2x plus 3y equals 15. And it was usually a scenario of buying something and buying something else. And what we found is that we couldn't buy half of a t-shirt to be able to get more hats. And so those would be discrete because there's only specific points that are on the graph. The actual book definition is the domain of a function is continuous when it includes all real numbers. Okay, so continuous means it includes, in our domain, in our range, includes all real numbers. And discrete, it's not, I wouldn't call it the opposite of continuous, but the domain of a function, all real numbers, that's for the domain. So remember our domain is our inputs, so our domain. And then for this one, for discrete, it only includes integers and whole numbers. And again, we're talking about the domain. So for a continuous one, I can plug in, for x, I can plug in the square root of 2, which we know is not an integer it is a real number, but it's not an integer, right? And I can plug in the square root of 2 and get an output for y, and it will be on the line. If it's discrete and I plug in the square root of 2, I broke it. It's not going to work. I have to plug in an integer or a whole number. So 1, 2, 3, 4, negative 1, 2, 3, 4, something like that. It won't work with fractions or irrational numbers. Okay, and then one-to-one. A function is one-to-one if no two elements of the domain map to the same element of the range. So what that's saying is it's one-to-one if we don't have two x's. So let's say we have, here's our x's and y's, and we don't have, so we have 1, 2, 2, 4, 3, 6, okay, something like this. And another way that they'll draw this is something kind of like this, and they'll have 1, 2, 3, 4, and then over here we have our, so these are our inputs, these are our outputs, and we have 2, 8, 7, 6. Okay, so if it is one-to-one, then each number in our x is going to go to something in our y. If it's not one-to-one, then we could have something like 4 goes to 8, but 2 also goes to 8. That would be not one-to-one. Okay, this one, these would all continue to work out. So 2, 3, 4 would be 8, 5 would be 10. Okay, this one's one-to-one. Every x has its own y value. This one is not one-to-one because 2 goes to 8, but 4 also goes to 8. That doesn't work. Okay, and that I think is a good intro for this topic. And we'll try and do one other video that just has some examples.